Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody watching us from the future. So today we will finish just a few more slides on the queries with SQL so that you know how to nest your queries. And then we will dive into database design theory, which is a theory part again, but you will see that it's actually very practical because this is about how you get your schemas right when you are in a company. So let me finish these few slides that we have. Then I'll ask you a clicker question, and then we'll move over. All right. So this is where I left you, I think, last time with these values, this way to put values into tables. I also told you this was not the first time we saw that, but because you might remember that in the first weeks of the semester, I showed you how to insert values in a table. And the command for that is insert into the name of the table, values, blah, 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 blah. And it is the same values, blah, 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 that you can actually use on its own without insert into, without anything, just values and the values in there. Of course, you still need a few commas and parentheses to put the right way so that you're clear where are the rows, where are the columns. So you need a parenthesis for every row, every record. And then within a record, within a row, you separate with a comma, right? Just like in a CSV. Yep, that's pretty much it. So this is an example where I have two records, foo1, and the second record is bar2. But of course, when you do that, there's no names for the attributes, right? There are no domains, there's nothing. So PostgreSQL is just figuring it out on its own, right? It's just going to make up column names. So typically it's going to call them column1, column2. It varies, of course, depending on the software you use. Some other relational database management system might call them col1, col2. I mean, you have to look at the documentation, right? But basically, this is what it does. It creates a table out of values. So this is another example where you have 3 records and 2 values. And by default, it's just assuming it's text if it's just a string. So you see it's very basic, but it gets the value into shape. There are ways, by the way, to cast the values to dates or other things. I just didn't show it to you, even though it might be on some slides in the other weeks. But there is a way to force some specific types in the query. Right? I just didn't want to overload the slides. And so, as a general rule, wherever in a query you can put a select from where, then you can also put a values instead, right? The values get exactly at the same places where you can have a select from where. That means in particular at the top level, because a query can consist of select from where on its own. The same is true for values. If you just put in your Jupyter notebook values, blah, 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 it works, right? So you can really consider them as at the same level in the query language. For whom is that clear? All right, very good. So now, so this is how you turn scalars into tables with this values magical formula. Then how, when you have a single scalar, you can also use a select statement like this select one as A, that also works. And that creates a table like this, right? So you can also do it that way. What is magical is that it also works the other way around. If you wrote a query that so happens to produce a table that has 1 row and 1 column, like this, then you are allowed to put that query that you know returns just 1 row, just 1 column, wherever a value is expected, a single value, right? So for example, you can write something like this. This is a query that reads the table spaceships, and it just selects the max of the war, right? You can do it without group by the way, the max min count. It's just going to do it on the entire table. So if I select max of war, then you get 9975, right? You get that. That is an example of a query that returns just 1 row and just 1 column. And so what you can then do is things like this. You can add a few parentheses around it, and then as if it were a number, multiply it. That is going to work. So technically, it's a table with 1 row, 1 column, but it's just automatically, it's called atomization. It's atomizing it to that value, multiplying, and that's how it works. And if you put that back inside a select blah as result, then you turn it back into a table, right? This is just as an example. It's not very interesting to do this, but I'm just showing to you that you can turn values into tables and tables into values in that way. Maybe I should remove if I manage to remove that. Oh, I need to add you as a co-host. Yeah. Oh. Yeah, some people. Okay. We just realized that we didn't press the button, but don't worry. We didn't do much yet. So let me make you a co-host. Sorry about that. So you can watch the recording, but basically I was just showing to you that you can do these sort of things in SQL. So select max warp from spaceships is technically a query that returns the tables with one row and one column, and you are allowed to put it in an expression that would expect one single value, like times 1.001, and it's atomizing it to a number. And then you can put it back into a select statement, and then you get back something that is a table. So what I'm showing here is that you can turn scalars into tables, and you can turn tables into scalars, right? Okay. So here's another example where you see that you have a query that returns a single column and a single row. So again, for those who are on Zoom, this is the query that just takes a max and only that. So it returns a table with just one row, just one column. And so you are allowed to put it inside a where clause, for example, where warp equals, so you could put a constant in there, right? Where warp equals 10. But instead of putting a constant, you can also nest this select max warp from spaceships, which is a table with one row, one column. It will be atomized to a number, and then you use it in your where clause, right? This is in fact computing an argmax, right? Mathematicians called it an argmax when you find the value that corresponds to the max, okay? All right, so it's very common actually to do that sort of things where you nest a query inside the where clause in that way, right? Very common thing to do. Here's another common thing to do. You can also use the in clause in the where statement. So you can test whether the captain is in a specific list. And here you can also use a select from where, but this select from where can return any numbers of values you want, right? As many records as you want. It just needs to have one column because you want to compare the captain to something in a list. So if you have a table that returns one column and many records, you can use this in statement in there, okay? So yeah, that's it. So this is very typical to do. So really try to take a snapshot of this. It's something that people really do a lot in practice, these things. Okay. Another way to nest, that would be a table inside a table. You basically do select from, and inside the from, where normally you would put a table name, well, instead of that, you can just nest yet another select from where, right? So you can basically, the inner one is going to return 5 columns taken from a join, right? So the one in the middle, and the outer query is a projection, right? So this returns a table with 5 columns, and this one projects to these 3 columns right there, okay? And then if you use as after the nested query, you can change the name. So you can select a new table name, give it a name, and then you can rename the columns, right? So these are the 5 columns that you selected from your join, and then you can give them new names like first, last century, starships, ship warp. And then you can use, of course, this name because this is in the from clause that you specify that. And then in a select clause, you can select using the names that you put in there. Okay? So you can nest a select inside a select. And because I told you that the values of last time when I told you this value is interchangeable with the select, it means that wherever you put a select, you can also put values. So it means that if I go back to the query that is here, You could also put inside of the inner select, you could put values like select first name, last name, name from values, and even with the as keyword after values, okay? So you see that it's like a Lego game, right? You can just combine a bit in any way you want and build more complex queries in this way, okay? All right, so this is an example of what I've just said. So you see the only difference here is that in fact, instead of this inner select, I have a values. So select from values, blah, 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 followed by the as TSN. And this is how I can control the names, because here it would just make up colon 1, colon 2. But if I add this as TSN, then I'm forcing the name to be S and to be N, right? And the table will be called T. And this S and this N, you can even use them in the select as if it were a table read from somewhere or anything. So you see, in the from clause, we already saw 4 different things you can have. You can have just the name of a table. That's the easiest you can have. You can have joins, Cartesian products, joins, theta joins, outer joins, and so on. Or you can have a nested select from where, or you can have a nested values, right? So these are the 4 things you can do in the from clause. So the from clause can very quickly get very complex. Okay? Who is with me? All right. Do not take it too lightly. This, what I'm showing to you here, can get very, very complex, right? It's as when you start nested queries into each other, it can really, really get complex. So you really need to understand the sort of things you can have in a query and how they nest together. But the best way to learn that is to just do it. So open a Jupyter notebook, write your queries, see what happens, try it out. Yes? Maybe I can give you this. We'll make sure it's switched on. Yeah, so slide view. I will rewind on the slides, so switch that on. All right, is it working? Yeah, maybe we need to activate the battery. Let's see inside. Otherwise, I just repeat. Now it's switched on.
Thank you. Can you come back on the slide 15, please?
15, yeah.
Yes, here, could we have something like where captain, comma, spaceship in select name, comma, something from, so instead of having just one
column, several columns.
Several columns. And
that's a good question. I don't know. So it might be, can you test it? Maybe you test it during the lecture and tell us. Otherwise, we can go offline. It could be, I could very well imagine that this is a load. I could also imagine that it's not a load if they wanted to keep it simple, but yeah, that's a very good point. And of course, that's not all of SQL, right? There's many, many more complex things that I haven't shown you. Yeah, okay. So you can interrupt us later, Xiaocheng, and let us know if you figure out if that's possible. Any other questions? Okay. So then maybe I will ask you one question on the Clicker app. Right here. Can you tell me what this is? Is this an inner join combined with 2 selections? Is it an inner join followed by a selection and projection? Is it a full outer join combined with a selection and a projection? Or is it a natural join combined with a projection? I'm basically asking you to interpret that query in terms of the relational algebra. We have a, oh, wow, we don't really have a majority. We do have a majority now, relative majority. Okay, well, you can still change your answer. Why is it not a natural join?
Because you have to rename the.
Exactly, you are specifying a predicate here. In a natural join, you don't. The natural join, you take the columns with the same names. But here you have this on p.pad equals s.product. So it's not a natural join. It's a theta join, a normal join. Why is it not a full outer join?
Because join is join.
Exactly, by default, it's an inner join. If you want a full outer join, you would write full outer join. So that's how you would see it. You would see explicitly full outer join. So since it's not written explicitly full outer join, then it's an inner join, right? And then that remains, that leaves us with the first two answers, two selections or selection projection. Well, in the where clause, you have a selection predicate. So there is a selection. But in the select clause, that's a projection, right? In the select clause, it's always a trap not to fall into. What you have is in the select clause is a projection. It's the name of the columns, the names of the columns that you take. So it's an inner join followed by a selection and projection for these reasons. Okay. All right. So basically, you could argue, like those who said a join with two selections, you could have considered that on is a selection, but it's part of the join. When you have join on, that's just the predicate of the join. So it could be implemented as a selection on a Cartesian product, but technically, we view it as a join in that case. Okay. So we're actually done with this part on queries with SQL. Any other questions? Nothing? All right. Then we'll move to, again, a theoretical part. I'll stop the recording. I cannot even see myself.